Beam-Slab Raft Foundation. Why do some raft foundations crack, become too thick, or cost more than they should? The answer might be punching shear, and this is where the beam and raft foundation comes in. In this video, I'll explain what a beam and raft foundation is, why ground beams are introduced, and why engineers argue about upstand versus downstand beams. What is a beam and raft foundation? Plans showing columns and ground beams. A beam and raft foundation is a type of shallow foundation where ground beams are integrated into a raft slab along column grid lines. The aim is simple: improve structural performance, reduce slab thickness, and ultimately lower construction cost. To design this system properly, both the raft slab and ground beams must be adequately sized and reinforced, while ensuring that soil-bearing capacity is not exceeded. The problem with flat slab raft foundation: in flat slab raft design, punching shear is often the governing design criterion. This usually forces engineers to adopt very thick slabs, which directly increases construction cost. How ground beams solve the problem? By introducing ground beams along column lines, the column load is transferred through the beams, eliminating punching shear in the slab. This allows the designer to use thinner raft slabs, larger, well-reinforced ground beams, and a more economical foundation system. Load transfer mechanism. In beam and raft foundations, the design assumption is that the raft slab first resists the earth pressure generated by the superstructure load, and then transfers this load to the ground beams. Because of this, the raft slab is assumed to carry a uniformly distributed load, which is then used for ground beam design. Slab behavior, very important point. Unlike suspended slabs, the raft slab behaves differently. Due to upward soil pressure, the top fiber is in tension at mid-span, sagging zones, while the bottom fiber is in tension at support regions. This is the reverse of what we normally see in suspended solid slab design. Upstand versus downstand ground beams. Beam-slab raft foundations can be designed with either upstand beams or downstand beams. However, the theory only works if the raft slab is in direct contact with the ground and stiff enough to resist soil pressure. The risk with downstand beams. With downstand beams, the ground floor level is achieved by filling above natural ground level. If this imported fill is poorly compacted, or of low quality, it will settle over time. When that happens, the raft slab starts behaving like a suspended slab, and the entire design assumption is compromised. For downstand beam systems to work safely, the fill material must be well compacted and preferably granular material. Which is better? Upstand beams are theoretically more reliable because the slab bears directly on natural ground, but they are usually more expensive due to extra oversight concrete. Downstand beams, on the other hand, can be more economical because the raft slab also serves as the oversight concrete, but only if the fill is properly compacted. So, beam and raft foundation design is not just about concrete and steel, it's about soil behavior, construction quality, and correct assumptions. If you found this helpful, like, share, and follow for more practical civil engineering insights.